All right, part two. So what we're going to do is we're not going to just look at finding it at the slope of a tangent line at a particular point. We want to be able to find it at all points of my graph, right? So if I think back to my very first problem, here's my parabola. I want to be able to find a tangent for any single point along the way, okay? So how are we going to do that? So here is my problem. It says find the slope formula for this function, negative 2x plus 4. So we have to remember the slope, right, aka our secant line, is going to say the limit as h approaches 0 of f of x plus h minus f of x all over h. So now instead of a point where we're going to be plugging in x, we're plugging in a whole function. Okay, so we're going to say f of x plus h. So that means everywhere I see an x, I'm going to plug in x plus h. And then plus 4, so this gives you negative 2x minus 2h plus 4. Obviously, f of x is just negative 2x plus 4. So we're going to say the limit as h approaches 0 of negative 2x minus 2h plus 4. So that's my first one, minus negative 2x plus 4 all over h. It's very important to use parentheses, especially for the second problem when we're finding the slope formula. So what are we going to get? The limit as h approaches 0. So we drop the parentheses on the first one. It doesn't really affect anything. Here, the two negatives are going to cancel each other out, leaving with a 2x, and we're going to get a negative 4. Here's the very important thing to remember. Just like on the previous problem, where this 8 and this 8 always disappeared, or on this problem, this 4 and this 4 disappeared, on here, everything that was in here is going to disappear. So notice I have a 2x, notice I have a negative 2x. So these guys are going to cancel. Notice here I have a negative 4, notice I have a positive 4 here. Again, those are going to cancel. If you don't get those to cancel, you've done something wrong. Okay, so the limit as h approaches 0, I'll just be left with negative 2h all over h. What's going to happen? My h's are going to cancel out. So I'll just be left with the limit as h approaches 0 of negative 2. There are no h's to plug in, so that means no matter what, my formula will just be negative 2. This is my formula. So that means at any point along the line, that's what my slope should be. And that should make sense, because what did I give you? I gave you a line. Lines are always consistent. So we're always consistent by what we have. So if you think about it, here's a quick little picture of our slope of our line, right? So any point along this line is always going to have the slope of negative 2. So we actually didn't need to do any work here in order to know that your slope formula was going to be negative 2. But I wanted us to have good practice, okay? What happens when things are not going to be a line? So let's take a look at our second problem. So our second problem is a parabola. So it's safe to say that the slope at this point versus this point versus this point, they're all going to be different. Okay. So here's our problem. We want to find the formula for slope of this one. F of x is equal to x squared plus 1. And then I'm going to go one step further. I want to find the slope of these actual points. Okay. So again, I'm going to come up with my formula. So slope is the limit as h approaches 0 of basically my slope, x plus h minus f of x all over h. Again, if I plug a 0 in, everything cancels away. Okay, so over here, I'm going to plug in, so f of x plus h. A lot of substitution. That's all this is. All right, so this is x plus h times x plus h plus 1. So this gives you x squared, xh, so 2xh plus h squared plus 1. So we're done here. F of x, that's the same thing right here. So limit as h approaches 0, parentheses, x squared plus 2xh plus h squared plus 1 minus parentheses x squared plus 1 all over h It's a lot of writing out the limit as h approaches 0. I get it, it's time consuming. But we have to do it. So again, notice x squared, negative x squared, positive x squared. Boom, gone. Negative 1, positive 1. So basically anything that doesn't have an h kind of goes away if you think about it. So limit as h approaches 0 will be 2xh plus h squared all over h. H is canceled away, leaving you with 2x plus h. So again, I want to figure out what my formula is, so I'm going to plug a 0 in. So I plug a 0 in 2x plus 0. So here is my formula. All right, so 2x is my formula. So that means I should be able to use this for any point, so to speak. So my 2 points, come back over here, was negative 1 comma 2. So negative 1 comma 2. So that means I'm going to find the slope at this point. So that means I'm going to say 2 times negative 1. So my slope should be negative 2. And if I look at my graph at the point negative 1 comma 2, that makes sense. It should be a negative slope right there. Okay. The second point that we wanted to find is 2 comma 5. So at the point 2 comma 5, I'm going to plug a 2 in. So 2 times 2, which gives me 4. So here's my slope at that point. So 2 comma 5. So 2 comma 5 should be right about there. And again, notice it's a positive slope over here, and it's probably going to be a little bit more steep than a point down here. Okay, something to keep in mind. This is very, very important when finding a formula. So finding formula for slope at any point except for linear will always produce a function of x. Okay, will always, no matter what, 100% of the time. All right, so now that we know that, why don't you pause the video, try this last one. It's another parabola, right? And we want to find the points at negative 3 comma 7 and at 1 comma negative 1. So go ahead, try your luck here. If we're coming back from the paused video, what we should have said is that the slope as the limit of h approaches 0 of f of x plus h minus f of x all over h. So basically what I want to do is I want to figure out what is x plus h in here. So x plus h times x plus h one more time. So x squared plus 2xh minus 2 plus, I forgot the plus h squared. Don't forget that. Okay, so we're right back here. So limit as h approaches this. So x squared plus 2xh plus h squared minus 2, and then minus everything, x squared minus 2. So again, make sure you put those in parentheses. Limit h approaches 0, x squared plus 2xh plus h squared minus 2, and then minus x squared plus 2. So simplifying, again, that goes away. This goes away. So everything that was in that parentheses always goes away. Limit h approaches 0, 2xh plus h squared all over h. Some h's are going to go away, which is exciting. 2x plus h. Plug in a 0 in for h. So our formula is just going to be 2x. So then we want to find the points. So what were our points one more time? Negative 3, 7. And what was the other one? 1, negative 1. Those points are on the graph, right? So it's not just arbitrary. Those are not just arbitrary points. right? So 1, -1 is on our graph, and then 3, -7 is on our graph over there. So again, notice that this one is pretty close. This is going to be a positive, so this is 1, -1. This will be a positive slope. This is -3, 7. This will be a negative slope, and it's probably a little bit steeper for that. So I'm just going to say 2 times -3. So my slope should be 6. So slope. And then here, this will be 2 times 1. So this will be 2. Again, we can always fall back on what we did at the very beginning of the lesson. We can plug in those points. We plug them in those points here, so we can do all of this work to find the points and get -4. But if all of a sudden we just come up with a formula, that means that you don't have to keep plugging in things. Okay. Now, what you guys are actually doing is you are coming up with a formula, aka you are deriving a new function, right? So you're actually doing a little bit of calculus known as derivatives, right? So maybe if you have friends that are in calculus, you're like, what is a derivative, right? You actually now know what a derivative is, because you're doing it, you're deriving an equation. Okay, so definition of the derivative. Oops, I think I spelled it wrong. Hold on. Take that away. So of the derivative, so we can say this. We can say f prime of x is equal to the limit as h approaches 0 of x plus h minus f of x all over h, provided the limit exists. So aka the derivative is just your is just representing your function, right? What your slope is called, right? So a derived function is called the derivative. Okay, and we definitely use f prime x, so it says f prime of x. Okay, so again, derivative is a formula. So derivative is a formula for slope of a tangent line, right, to the graph of f at the point x, f of x. So all it is just a different notation. So in part 3, we're just going to use that different notation to help us with a few more examples.